Bismillahirrahmanirrahim. Assalamu alaikum. How are you, my dear students? Hope you will be fine and okay. Today is our lecture number fifth, unit number 7, properties of matter. In our today lecture, I will tell you about the Archimedes principle, density of an object, principle of flotation. Now, let us start with the name of Allah Almighty. Bismillah Rahman Rahim. The first topic is the Archimedes principle. Now, what is the Archimedes principle? Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces. Now, what is the buoyant force? This is the, sometimes we call it the upthrust. Now, what is this upthrust? This upthrust is the weight, the force which the fluid, liquid or gas, which the fluid exerts on objects in the upward direction. So that is called the buoyant force or the upward force. Right? Fluid is anything which has the ability to flow. So that may be liquid or gases, you can say both. Okay, whether fully or partially submerged is equal to the weight of the fluid that the body displaces. Now, what is this principle? According to the Archimedes principle, in a very simple manner, that whenever an object is immersed partially or wholly in a liquid, then the object experience a bind or the upward force which is equal to the weight of the liquid displaced by that object. That is the easiest way. This Archimedes principle make it possible for the ships to float on the surface of the water, for the submarines to rise and sink into the water, the fish floating deep inside the water, and the rise of the fish on the surface of the water, that are all based on the Archimedes principle. And the way in which we are measuring the density of the liquid, known as the device which is known as the hydrometer, that is that work on the principle of the Archimedes principle. Another important thing, the float test, even when used by the common people, even who don't know the word about the Archimedes principle, and they can easily tell you whether the eggs are fresh or rotten. So this is all are based on the principle of what? On the principle of the Archimedes. Similarly, you might have noticed that it is easier to lift things in water rather than on the ground. That is one of the basic reason, or some Archimedes principle is one of the basic reason behind it. Sometime you might have noticed that a sink which is made up of steel sinks into the water, while a huge ship made up of the same steel, it float on the surface of the water. The answer is again the Archimedes principle. So the Archimedes principle tells about the designing of the ship and submarine, the fish floating on the water surface and inside, and the hydrometer, which is used to determine the density of the liquid, and a float test. Now, the upthrust force that acts on the liquid when you immerse an object on the liquid depends on the most few important factors. Now, what are those factors? This bind force, it depends first the density of the fluid, density of the object, sorry. It is what? The density of the object. Second, it depends on what? It depends on the what is it? It depends on the volume, the oh, I'm so sorry. This is the density of the fluid. I'm very sorry for that. The density of the fluid. This is the volume of the object displaced by the liquid. Displaced the this is the volume of the liquid displaced by the object, displaced by the object, which is equal to the which is equal to the portion of the object that is immersed in the water. And this is the gravitational acceleration. So the buoyant force, the F force, or this buoyant force or this upthrust force is directly proportional to the density, and it is directly proportional for G constant there to the volume of an object, right? So let us, before deriving this equation, let me explain these terms to you. Look, that why the ship float on the surface of the water. The ship is designed in such a way that the volume is made so large. As you see, look at the volume of the ship here. The volume of the ship is made so large that the ship is what? That the buoyant force acting on it is greater than the weight of the ship, and as a result which the ship float on the surface of the water. So that is the volume effect, that how the volume causes the volume causes the buoyant force to increase. Similarly, look at the density factor. The greater the density of the liquid, there will be a greater upthrust or buoyant force acting on the body, on the object. For example, that more saltish water have what has a greater density than the pure normal water, and therefore the upthrust of the fluid acting on the object will be greater as the density of the saltish water is greater. Another important point is that this density varies with what? With the temperature also. So for example, in the morning, the water density is what is the density? Mass per unit volume. So in the morning, the temperature is low, volume is low, and density is high. So there is a chance of greater upthrust on the ships and on the boats at night rather than on the day. So this could be really taken into account while you are boarding boarding people into the boat, right? Why? Because at daytime the density is what? The density is less, so the upthrust is less. At night time you can include more or two people, but at the daytime that will be dangerous. For example, this is just for the boat, not for the ship. The ship may be adjusted in this way, right? So that is the most significant phenomena here. So there are actually two forces acting on the ship. One, the weight of the ship that is acting downward, and the other is what? The other is the upthrust force of the fluid or the ocean on the ship. So as the upthrust is greater because of this density, because of the volume factor, so the upthrust force is greater than the weight, and that is one of the reason that it float. And this is just simple, known as the principle of flotation, and I will be coming to that point later on also. The same thing happens to the what? To the fish also. The fish has the ability to rise onto the surface and to sink as well, and there is a part of the fish known as the swim bladders, and they could adjust the volume of inside it, and that can cause the upthrust force to increase or decrease the swim bladders, right? So on that principle it works. Similarly, the submarine, if you see, look, the same principle is applied to the submarine also. The submarine can sink, as you see here, and it can what? And it can rise to the surface also in order to hide from the enemy. So there are the water tanks fitted right onto the top. So that is being filled with water by using motor and pumps, and that the volume of the water inside it increases, and sorry, the weight. I'm so sorry. The weight of the submarine increases due to the more water that are filled into the tanks, and the weight increases, and then the upthrust, and the submarine sinks to that particular level. In order to rise, the water tanks are being emptied into the ocean again by using pumps, and it gets lighter, and the upthrust becomes greater than the weight, and it then rise the top again. Okay, so that is all about the basic concepts and ideas of the Archimedes principle. Let us derive the Archimedes principle, that how we can derive the Archimedes principle. First of all, I just want to tell you one thing you must remember, that what is the reason for being this? The reason for being this, it is all because of what? This upthrust force, it is caused by what? It is caused due to what? Due to the, it is caused due to the difference of what? Due to the difference, due to the difference of the pressure on the two surfaces of the object, on the two surfaces of the object. Since these two surfaces, the pressure, there are what? There are pressure differences. So that pressure differences cause the force to act on the object, right? Or the object experience an upthrust force due to the fluid in the upward direction. How this happens? Because you know that the liquid pressure is directly proportional to the depth, right? So as the depth of the object increases, the pressure acting on it decreases. So in order to derive this principle, that let us then see that we have this cylindrical shape, as you see, like this one, cylindrical shape like this, inside the water, which has cross-sectional area A. This is the cross-sectional area A, right? The two cross-sectional area, one at the top and one at the bottom, they are the same. And the height of the depth of the top surface from the surface of the water, this is the water or the fluid surface, it is at the depth h1, and the bottom surface is at the depth h2. So if I just label this point as the point 1, and if I label this as the point 2, so the pressure experienced by the object at the pressure at the point what? At the point P1, at the point 1. So what is that pressure at the point 1? That, as we know, pressure is equal to rho GH. So at the point 1, the surface is at the depth H1. So this is the pressure P1. This is equation number 1. Now the object also experience pressure at the bottom surface. So at the point 2, at the point 2, what is going to happen? The pressure P2 is equal rho GH2. The pressure, the surface is at the surface area A, the bottom surface is at the depth H2, right? So both surfaces experiences what? Both the surfaces experiences pressure, and there is a pressure difference. Why? Is that is the pressure P2 is greater than the pressure P1. The reason is very simple. The reason is simple because it is due to the fact that the depth H2 is greater than H1. And this difference of the pressure cause actually the buoyant force that acts on the object in the upward direction. So since P2 is greater than P1, then may I write it like this? And what is P2? Rho G H2. And what is this? Rho G H1. And you see the rho G is common. This pressure difference is P2 minus P1. Let it be P, or let call it delta P. Okay, the change in the pressure. So it will be H2 minus H1. And now what is this H2 minus H1? This is the height of that cylindrical object, and that will be rho GH. Now, in order to know for the force, if this is what? If this is force F1, definitely this force F1 will be equal to pressure P1 into the top surface. And the force F2 will be equal to pressure P2 and pressure P2 times the area of the bottom surface. Since both the cylinder is uniform, so both surfaces are the same. So let multiply both sides by the area A, right? And this will be rho GH into A. Now, this is what? This is the volume of the object. Volume of the object, right? And this is what? This is the required force. That force is called the buoyant force, right? That force is called what? The buoyant force, FB, or the upthrust force. Maybe in your book it is written as F2 minus F1. Why? Because they did not change the P2 and P1 to delta P. So this will be equal to rho GV, or this FB will be equal to rho VG, where V is the volume of the object and D is the density of the rho is the density of the fluid. So now this is, what is this volume? This is volume of the object, which is right. This volume of the object will be equal to the volume of the liquid displaced by the object. Okay. So this is why that is the equal volume of the liquid displaced by the object. So this is the volume that is displaced by the volume of the water that is displaced by the object, the portion of the object which is in the water, right? For example, look at this here. So that is the volume, this one, like is this whole. So you see, this will come out to be like this. So this force, as I told you, that this upthrust force is equal to the weight of the liquid displaced by the object. How? Look, this is the density of the liquid. As you see, density of the liquid, rho, and this is the volume of the liquid that is displaced by the object, right? So density into volume, that becomes equal into what? Mass, right? Into G. Now what is this mass? Remember, this is not the mass of the object. Remember, it is the what? It is the mass of the volume of the liquid displaced by the object. Yeah, it is the mass of the liquid displaced by the object. Displaced by the object. Clear? So this buoyant force FB, this will be equal to what? Mg. And as I already wrote this thing, so what is now this? This is the weight of the liquid, weight of the liquid displaced by the displaced by the object. Displaced by what? Displaced by the object. So whenever an object is immersed in a fluid, wholly or partially, there acts a buoyant force on it, or there acts an upthrust on it, which is equal to the weight of the liquid displaced by that object. This is known as Archimedes principle, and much of the application I discussed with you. Now the density of an object, that how we can use this. The Archimedes principle is used to find out the density of the object, right? How the density of the object can be found. The density of the object can be found by using the Archimedes principle, by using the equation, which is this equation is given direct in your book. That is, according to this principle, that the ratio of the density of the object to that of the density of the fluid is always equal to the weight of the object in air, which I'll be writing W1, to the weight of the object equal to the weight of the uh, object in the water. That is the what I would like to tell, that the upthrust, not the weight, sorry, the upthrust of the liquid acting on the object. Now let me tell you first, for let me make a diagram for you like this one. As you see, look, if we have the kind of object like this one is our object, as you see. So this object has weight, and the weight of the object, it always acts vertically downward. Let me call this weight as W1. So this is weight in air, weight of the object in air, right? Now when you place that object in water, right, and when you measure the weight of the weight of the object decreases. Why? Due to the upthrust force acting on the object in the upward direction. So this is actually this W2. This W2, this W2, it is the weight of the object in water, right? And the combined W minus 1 combined, this is in fact what? So this will be in fact the upthrust. So the ratio of the density of the object to that of the density of the fluid is always equal to the weight of the object in air and to the upthrust acting on it when it is placed in or immersed in a water. So the density of the object will be equal to what? It will be equal to W1 into W1 minus W2 into rho. So if the liquid is water, if your liquid is water, then this will be equal to 1000 kilogram per meter cube. This rho will be like this. So this is the formula which can be used to calculate what? To calculate the density of the object. So this is very easy. And this could be one of your practical also in the lab. You can perform this, right? Now the principle of flotation. I think the next topic would be this one. Principle, the principle of flotation. Now, what is the principle of flotation? The principle of flotation tells us that a floating object displaces a fluid having weight equal to the weight of the object. Very simple. That it is nothing but the Archimedes principle. So in order to explain the principle of flotation, there are two important points. First, let me explain you the first one, the sinking, that when the object will sinking. Now, the sinking of the object can be explained like this. For example, let us suppose that if we have the water, as you see, let me make the water here, right? As you see, this is water. Now, when you immerse an object inside the water, for example, let we have this object which is immersed in the water, right? This is the object. Okay, so this is the object inside what? The inside the water, as you see, look. This is the object. Okay, let me do this with a pen. Okay, this is the object. Now, on this object, there are two forces acting. One, the weight of the object, that is in the downward direction, which is equal to mg. As the object is sinking inside the water, and there is another force acting on the object, and that force movement before I explain the upthrust. So the sinking will happen if we just see, look at the resultant force, that F, the weight of the object, is greater than the buoyant force acting on it, right? That look, the net force, the F net force. If the weight is greater, then what? If the weight is greater than the buoyant force, so the total, the F net force increases, that is the net force, right? If the weight of the object is greater than the F buoyant force, then the F net force, right, that will act in the downward direction. In this F net force, I will just make it like this, the resultant force, this one, which is acting on the object in the downward direction. My God. Sorry. Okay, let me use another color pen. The F net force acting on the object will be what? It will be in the downward direction. You see, look, this F net force acting in the downward direction, right? Why? Because if W is greater than FB, and there the object will what? The object will sink. Similarly, this is one part. Another, or we can say that if the average density of the object, the overall density, right? If the density of the object, if the density of the object is greater than water, then that of the density of the liquid, that of the density of what? Density of the liquid, the object will what? The object will sink. The object will sink, right? That is, but as I told you that I use the word the entire, the average density. Why? Because it is not true in the sense that if you know this equation, like the F buoyant force equal rho Vg. So as I told you, look at the needle sink, though the density of the needle is what? The density of the needle is smaller than the density of what? The density of the needle being steel is greater than the density of what? Is greater than the density of the water, and so it sinks. But look, ship made up of steel also, it does not. Why? But its average density is lesser or smaller than that of the density of the water, so it float. The second point is sinking. How the object sink. Sorry, I'm so sorry, floating. how the object float. The same equation now, but the net force, the F net, the total force, when the net force is such that the bind force acting on the object due to its large volume or greater density of the liquid is greater than that of the weight of an object, then what will happen? In this case, if B is greater than F this, then the net force, the F net, it will act purely in which direction? In the upward direction, the F net, right? And the object will what? Float. Or we can say this is part A. And in the second part, like this density greater than this, or in this case, density of the object less than density of the fluid, the object will float. For example, a tennis ball. Clear? So that is known as the flotation or the floating principle, right? Another important point, which is that is principle of flotation. I told the same is the situation in the case of what? In the case of the ships and submarines. The same I already explained to you, but I will now explain to you about what? About the mm, I will explain to you how we can find fresh or the fresh or the rotten eggs. For example, look, you see here the fresh egg, right? It is right at the bottom. You see the 15 days old egg, some part of the float and some part immersed in a water. In the rotten egg, you see, look, what is happening? Much of the part is what out and less part is inside the water. How? It is very simple here. Look, what is the density of the object? Density is what? Mass per unit volume. So if you see for the fresh egg, the yellow part is mostly concentrated at the center, and that is the denser part, right? More mass, and the whitish part stays outside. So for the pure egg, they are all concentrated at the center. So more mass is gathered at the center, and the volume is less and the density is greater. And this is one of the reasons that the pure egg sinks much more into the water. For the as the eggs becomes older and older, the yellow part just spreads, right? And what happens? That the volume increases and the density decreases, and it rises to the top surface. For the rotten egg, what happens? Much of the yellowish part spreads all around the part of the egg, and the volume is now very much larger, right? And the density decrease considerably, and the weight of the egg, the upthrust, the upthrust on it is greater than the weight of the egg, and the egg float. So rotten eggs always rises to a top surface while the fresh egg sinks into the bottom. This is how a float test is used to find the fresh eggs, right? They are based on the principle of what? On the principle of flotation. Another reason could be when the eggs become rotten, then there produces hydrogen sulfide gas, right? Because when you smell it, smell very bad. So that gas is usually lighter than their density is lighter than the density of the water, and therefore it floats or it rises. So this is our today lecture about the Archimedes principle, the finding the density of the object and the principle of flotation, and about the working of the ships and the submarine and various other examples which were included in my this lecture. So inshallah, see you in the next lecture where I will teach you about the elasticity, Hooke law, etc. So thank you very much, and Allah Hafiz.